I'm Geaho and I'm 16 years old and I go to Modern Day High School, and this is my Rocker-bogie system. And throughout the process of this robot, I've used the RSDLC, which is System Development Lifecycle. And basically this lifecycle is used by many engineers to help them think through their process, as you can say. So there's a goal which they have in mind, and they have a design based off of the goal. And after that, they have a design, they can build off of it, and program, test it, and then you go to rethink, which is the most important stage. What can have been improved upon this process? And so at this stage, we think maybe I can add a better processor, better parts, or something like that. And then you continue to play, test it out, maybe give it to some people, beta testing. And you have back to goal again. What could be better and what could maybe even better? And so the goal of my project was to integrate the Rocker-bogie system. And you might ask, what's the Rocker-bogie system? Well, it's right there, and it's used in the Mars rover. And basically what it does is that it's a suspension system without using any tension like spring or hydraulics. So when it's in space, you might have those error like a leakage in the suspension system, which you don't want. Or maybe over time, gradually the suspension system deteriorates. And so what they thought was that you use pivot points instead, which lasts much longer, and it can have the same performance as a suspension system. And design, so I spent around 2 weeks looking through the internet, a recreation of this system, and throughout all the images I looked through, I found the one recurring pattern, which is it has an arch, and a smaller arch, and connected by 5 pivot points. So it's 1, 2, 3, 4, 5. And build. So I use Vex parts, which is commonly used in competitive robotics. And this presented many problems since it's not the most flexible part to use with, such as Lego, but it got the job done. So programming. So I use Arduino, which is a linear algebra right there, and it uses C base, which is not exactly C, but is not C++ either. It is a base form of it, but it's called C base. And so test. So I spent most of my time actually testing the structural integrity of the robot, like having this little bar here. The problem was that the arches themselves were actually collapsing on itself because of the material I used, which is steel. So it's very heavy and not very, and so my structure couldn't handle the stress, so I had to add a lot of arches, maybe rethink some designs here and there. And so when I rethought of this, I was, like I said, I had arch plates through here, add another plate here, so it has a dual plate here, so I can hold the pivot points better in place. So this is actually my first full cycle, as to say, of the RSDLC, in which I went through programming and building and designing. So today I finished debugging the circuitry, which got the motors working, and then presented another problem, which is that the wheels themselves bent inwards so that it collided with one another when it ran. So that's another problem I have to fix later in the future. So yeah, any questions? Yes. Yeah.
Can we watch it run?
Yeah. All right. I'll give it a sec. There it goes. So I set the program to run for 15 seconds. They should stop. And 15 seconds is a long time, so you might have to wait a little longer. So any other questions? Any more questions? Yeah.
So what's a giant black brick that you have there? What is that?
Oh, okay. So this is the battery I have, which is 12 volt and 3 amps, which is more than enough to power up all 4 of these motors. So that's the power supply that powers the motor controller and Arduino. Yeah.
Are you putting the weight of that under consideration? Because you said you had a weight issue.
Okay, so I didn't have that much time to actually, my original plan was to have a cradle here, so the center of mass is centered here, and so it shouldn't affect the weight distribution too much. but didn't have that much time, so I have to stick with holding the battery and running with it. Yeah.
I'm just having a little bit of trouble seeing. How does that replace a suspension system?
Okay, so basically it has a tolerance rate of 45 degrees.
Mhm.
So any object at a 45 degrees and 80 to 60% of its maximum height here, just right here. As you can see, I think that's around 16 inches the last time I measured.
Okay.
So it should tolerate around 10 inches of obstacles, 90 degrees.
Okay.
So it technically should able to drive right over it, and supposedly this hinge right here should able to stay level to the ground, or as close as level so it won't move as much. So which is basically what a suspension system does. It carries the load at a same place without turning. Any more questions?
All right, good job, Geaho. Give him a round of applause.
All right.